This is Carrie Lesmeister, and this is the recording for your Horntvedt math book over the chapter that covers calculations using weight and body surface area. So I will have integrity recording for you any week that we introduce a new math topic. You may have this taught live to you in lab, or you may be required to watch this video as part of your lab component of Nursing 227. There will be an upcoming quiz on this material, so it's important that you review the integrity and that you understand and are capable to perform these calculations in preparation for that quiz. So let's look at what our objectives are. We're using our Horntvedt math book, and we're going to use both body weight as well as body surface area today to figure out how much medication to give a client. At some point in these problems, we're also going to be given height and weight, and we're going to use two different formulas to figure out body surface area. Sometimes a healthcare provider will use body surface area because it's a more accurate way to administer a medication, and so a lot of times we see body surface area, or BSA, used in chemotherapeutic agents. The main thing we want to keep in mind is that the goal of this is to give a more accurate dose, and so it's very important that we have an accurate weight for that client, and so we're using a scale that's reliable or consistent, and we're ensuring that we're not just taking a stated weight from the client. All right, so we're going to jump right into a problem here. I'm going to let you pause if you want to really look and study this question. I want to point out a couple of things. The first thing is going to be that I always will tell you on your quizzes and exams for Nursing 227 exactly what you're looking for, and I will also always tell you how to round. So that last sentence in this problem tells us that we are looking for milligrams, and then I also have rounding instructions. Keep in mind that we're always going to round at the completion of the problem and never before that point. So when we look at this problem, we need to start thinking about dimensional analysis. And so when we think about dimensional analysis, the first step is always identifying what we're looking for. And I tell you that right here, that we are looking for milligrams. How many milligrams are we going to give this client? So when we've identified what we're looking for, we always write that to the left of the equal sign. And we're going to write milligrams there. Students often struggle with math problems and they wonder how they know what goes on top and what goes on bottom. And so the beauty of dimensional analysis is that once you've identified what you're looking for, you know that that number has to be the numerator of that very first equation. So we're going to pull milligrams right over to that label. Now we're going to go up and we're going to look at our problem. We know we're looking at something with milligrams. When we look at our problem, that healthcare provider is saying that we want 0.75 milligrams per kilogram. Now, this per sign here is the same essentially as this horizontal line on the screen. This is a marriage, or this is a pair. That healthcare provider has ordered 0.75 milligrams per kilogram. Nurses do not prescribe. We're not advanced practice nurses, so we do not prescribe. We carry out those orders. So we need to, first of all, make sure that we keep this together because that's what the healthcare provider has ordered, and we need to ensure that we don't change any of this data. So when we look down here, we know that milligrams needs to be on top, and we see that milligrams is married to kilograms up here in our healthcare provider's order. So milligrams is on top, and then that means kilograms needs to go on the bottom. Next, we're going to just go ahead and enter that data from the problem. So 0.75 milligrams over that kilogram. Now, in this problem, 1 kilogram is implied. If you are confused and you want to write a 1 down on the bottom, you absolutely can. It will not change your answer one bit, so it's up to however you learn best. But we need to understand that the healthcare provider is saying that for every 1 kilogram that client weighs, we will administer 0.75 milligrams of medication. So when we look at the next step, we have our problem set up, we know what we were looking for, and we started out our problem with the numerator being what we're looking for. That was married to kilograms in the problem. Next, we need to look and find another given quantity. And so when we look at our labels here, we have kilogram at the bottom, and we want to get rid of kilogram because we're only looking for milligrams. So we then know that kilograms needs to be the numerator of that next equation. Then we're going to just look up at our problem and see what is left with kilograms. And we can see that the client's weight given is in kilograms. So to recap again what we did, we're going to always look for identify what we're looking for in that problem. We're looking for milligrams today. We write milligrams on the left side of that equation. We know milligrams needs to be carried over to that first numerator of that first equation, so we're going to put our milligrams there. Milligrams is over kilograms because in our problem, they're married in this equation, which is our healthcare provider's order. Milligrams over kilograms, and then we're going to just go ahead and enter our quantity. Now, we don't want kilograms left as a label, so we need to cancel out kilograms. We can cancel out kilograms by making it the numerator of this next equation, and we'll go ahead and enter that data from the problem, 74.6. We can then go ahead and cross out the label of kilograms, and we'll go ahead and carry out that multiplication on our calculator. We get an answer of 55.95, and we know that the only label left then is this red circled milligrams because these kilograms crossed each other out. Our rounding instructions said to round to the nearest whole milligram, and so we know that we have a whole number represented before a decimal, and we look at the first decimal after that place to identify if we need to round up or stay where we're at. If that first decimal is 5 or above, we will round up. Since it's a 9, we do go ahead and round up, and so our answer will be 56 milligrams. Now, on your quizzes and exams in Blackboard, you will just go ahead and type in 56. It will tell you specifically, do not type in a label. You only will type in the number. So let's look at another problem, and we did the first step already, and now we're going to do that same step with another problem, and then we're going to take it one step further. So when we look at this healthcare provider's order, we're going to give a medication, and we have a client weight, and we need to know how much we are going to give. And so our problem says calculate the dosage in milligrams. So again, we know what we're looking for. We're wondering how many milligrams will we administer. We always put what we're looking for on that left side of the equal sign, and then that label has to carry over and become the numerator of the very first equation in this problem. So we can go ahead and put milligrams, and then we're going to look at our problem and identify what's married to milligrams in the problem. So when we look at milligrams in the problem, we have milligrams married to kilograms. So when we look here, again, it happens to be the healthcare provider's order. And the healthcare provider says for every 1 kilogram that the client weighs, we're going to give 2 milligrams of this medication. So since we've got our labels in the correct spots, now we can plug in our numbers. This next equation just represents the numbers plugged in. When we look at the next step of this problem, I'm just going to recap again what we've done. We have milligrams as what we're solving for, so milligrams is our numerator. We're going to place milligrams over kilograms because that is what is identified in the problem as that marriage or that solid relationship. And so we have 2 milligrams per kilogram. Our next step then involves identifying how we're going to eliminate that kilogram label. And so the healthcare provider wants 2 milligrams per kilogram, and our client weighs 64.7 kilograms. So we can go ahead, and we know that if we put kilogram as a label of this next equation, we'll be able to eliminate that, and we'll be left with just milligrams. So we can go ahead then and enter the 64.7. We would multiply that out in our calculator. We can cancel out that kilogram label, and we get 129.4. Again, on our question rounding instructions, they say to round to the nearest whole milligram. So we look at this first place after the decimal, and since this is 4 or below, we remain with the answer where it is. So we are going to administer 129 milligrams. So the second step of this problem then is taking that data of how many milligrams we're going to give, and now we have this liquid medication in front of us, and we have our IV supplies, and now we need to figure out how much to give the client through that IV access. So again, we're going to do it the same way. We're going to identify what we're looking for. And so with part 2 of this question, they want to know how many milliliters do we give. We're asking for a liquid. So we are starting with milliliters, looking for milliliters. We know that milliliters has to be the numerator of that first equation. We look at, if you need to look back at this slide in part 2 of the problem, which I probably should have copied here, part 2. So we have 20 milligrams per milliliter, and then we're figuring out that volume. All right, and then we're going to round to the nearest tenth this time. All right, so let's go back to part 2, fast forward. All right, so we're looking for milliliters. Our milliliters in this problem is married to milligrams, and this is what has to stay together. We got this from a pharmaceutical company, and they have said there's X amount of milligrams in the volume of 1 milliliter. We can't change that, we can't separate, and we can't move those numbers around. That's a given. And so we can go ahead and we can put in that there is 20 milligrams in each milliliter of this medication. Again, if it helps you, go ahead and put a 1 up here. It will not change the answer or make any difference, but if that helps your mind to keep the problem straight, go right ahead and put a 1 in. So our next step then is going to be identifying what the next equation will be. So we're looking for milliliters in this problem. We have milligrams here, and that means we know that we need to eliminate milligrams as a label. So by putting milligrams up as the next numerator, we'll be able to eliminate that label. Next, we just look to the problem, and we want to identify how many milligrams we're going to give. So for this step, we're going to look back at part 1, and we are going to insert how many milligrams we figured out we were going to administer, which was 129. And then we're just going to go ahead and cross out our milligram labels, and we can enter this into our calculator. 129 divided by 20, we get 6.45. Now, when we look at our rounding instructions said to round to the nearest tenth. The nearest tenth is that first decimal. So we're going to round to this place, so we look at the next spot. This is 5 or greater, so then we round up. So we have 6.5 milliliters that we will administer to this client. Okay, so we're going to start on some body surface area problems. So body surface area, whether we identify body surface area from weight in pounds and height in inches, or whether we use kilograms and centimeters, we are always solving for meters squared. So meters squared is that body surface area. There's 2 different formulas for this, and I'm going to go through both formulas. We're solving for meters squared using kilograms and centimeters. You're always going to take your weight in kilograms times your height in centimeters, and you're going to divide this by 3,600. Now, these are equations that you do need to have memorized and have an understanding of for your quiz this week. I remember this because weight in kilograms and height in centimeters is used a lot in other parts of the world. I think of the globe as 360 degrees, and even though it's 3,600, I remember it's 3,600 based on the fact that a globe is 360 degrees. The next equation, I'll point that out in a minute. So whatever works for you to remember this equation, that's just what works for me. I remember that it's a globe, and that's how I can remember. So we're going to receive a problem such as this on the quiz this week, and we need to figure out how the body surface area is identified. So anytime that we're looking for that meters squared, again, and we have kilograms and centimeters, we're just going to go ahead and insert those numbers here. Our next step then is to multiply 93 times 192, and we get 17,856. We're going to take that divided by 3,600, because 3,600 is always what we divide kilograms and centimeters by for this type of problem. After we divide that out, we get, oh, my box is a little bit wrong there. So we multiply that out, and we get 4.96. And now we need to take and figure out the square root of 4.96. When you figure out the square root, you're just going to keep that 4.96 in your calculator, and you're going to push the square root function. Now, the most important part of this whole entire lecture is step number 4. Make sure you're paying attention and you understand this step. When we figure out body surface area, which is represented as meters squared, it's imperative that you round that number to the 100th. Now, this does not apply to your rounding instructions at the end of the problem. This rounding to the 100th applies to this metered square labeled number. You always, always, always need to leave this at the 100th spot or greater to get the most accurate answer. So even if in a problem, if I tell you to round to the nearest whole number or round to the nearest tenth, remember that means your final answer. We're not at the final answer yet. When you look at what the square root of 4.96 is, the square root of this number is 2.227. And we want that to be as accurate as possible. So when we're rounding to the nearest hundredth, we look at that next number. So we look at this 7, 5 or greater, we're going to round up. So this becomes a 3. So right now, all we need to know is that our body surface area is 2.23 meters squared. Get it in your mind that meters squared always has 2 decimal points. It has to be to the hundredth. A lot of students will keep the number in their calculator after they push that square root function for the next step of these problems, and that's absolutely fine. I have the quizzes worked out for a couple of different ways because some students will get a little bit more accurate than others. And so some answers may be slightly different depending on if you rounded or if you kept this square rooted number in your calculator. What will be wrong on a quiz is if you would go ahead and round your meters squared to 2.2. If you rounded it to that tenths spot, or if you just rounded it to 2 to the whole number, that will give you the wrong answer. So you have to have it to at least this hundredths position. Now, the other thing that students sometimes struggle with is how to put this into their calculator. So when I'm putting it into my calculator, I put in 93 for 93, the multiplication sign, times 192, and then I don't even put equals in. I just go right into divide. I push my divide sign and I divide by 3600. Then I push my equal sign, and that's what gives me my 4.96 up here. And then after I get my 4.96, after I've pushed this equal button, then I push my square root button, and that's when you'll get this answer, which you round to the hundredths place. Again, rewind this a little bit if you don't understand what I just said. This is imperative to get the correct answer. Make sure that you're comfortable with whatever type of a calculator you'll be using for the quiz and that you practice with it. And make sure that you know what sequence to put the numbers in to get the accurate answer. So, don't forget to push that square root button. Otherwise, you would enter a number which would need to be square rooted and would obviously be inaccurate. So again, I'm just trying to highlight how very important it is that you understand that you always are going to round to the hundredths position for body surface area. We follow the rounding instructions at the very end of the equation. Do not round any numbers before calculating that square root. That square root has to have 2 decimal places after it. If you push the square root button on your calculator and you happen to get an answer that perhaps was, 5.01, 0, you would still want to do 5.01. If you happen to get a number that was 5.1003, and again, I'm telling you, you have to round to this spot, then that would be a time where you could use just the 5.1 because we don't ever need the extra trailing zeros. So this applies when you don't have this type of a situation. But otherwise, if you have all numbers in there that aren't zeros, you're going to round no sooner than that hundredths position. All right, so when we look at how we do this with pounds and inches, we can see that meters squared is always a square rooted number, and we're always going to take the weight times the height, no matter if it's inches, centimeters, pounds, or kilograms. The difference is the denominator. So remember I said we use 360 for kilograms and centimeters because we use kilograms and centimeters all around the world, and that's 360 degrees. I remember this one because in the United States, a lot of us women love our 31 bags, the brand of bags that's 31. And so that's how I remember. It's 31, 31. So that's how my mind thinks. One year I had a student say something else worked for them. So go ahead and find something that helps you remember these equations because this is something that you need to have memorized, and it is not something that's provided to you on the quizzes and exams for this content. So we look at this problem. We have a client that's 143 pounds and 68 inches in height. So we're going to go ahead and put that into our problem. Again, we're looking for body surface area, which is identified by the label of meters squared. So we'll go ahead and take 143 times 68. And the next step then would be that gets to 97.24. And we're going to divide that by 3131 because we have pounds and inches. And we then get 3.11. We know we need to take the square root of that number, and we're going to round that to the hundredths place. Again, very, very, very important step. So we round to the hundredths place, and the hundredths place is right here. Since this is 4 or below, we do not have to round up. So this would stay at 1.76 meters squared. Again, this will give you one answer, and if we go to the next step and you kept this in your calculator, it may give you a slightly different answer, but I have the quiz set up for both options because I know that some of us will do different ways, and that's okay. We're getting the same answer. So again, when I put it into my calculator, I take 68 times 143, I push the divide button, I divide by 3131, I push equals, and then I push that square rooted number. Again, never rounding closer than the hundredths position. So we want to make sure we have that current height and weight. We also, when giving high-risk medications, we'll always have another nurse or a pharmacist double check our math. And if we get a order that's different or a number that's different than our provider has prescribed, we want to make sure that we're double checking that with someone as well. We're not going to just say, well, they're a pharmacist or they're a healthcare provider, so they must be right, I must be wrong, I'm just going to go ahead and give it. We want to always clarify when we don't have the same answer. So now we're going to go ahead and we're going to figure out our body surface area, and we're going to use that body surface area to figure out how many milliliters of a medication to give to a client. So when we look at this, we are going to give a cyclovir, and we're going to give 750 milligrams per meter squared. We have kilograms and we have centimeters given in the problem, so we know that the equation that we're going to use will have a 3600 on the bottom of it. So again, when we look for meters squared, we are going to take the kilograms times the centimeters and divide by 3600. So we're going to take 12,150 divided by 3600, and we get 3.375. Then we're going to take the square root of that number, and we get 1.84 meters squared. Now we look at the second part of the problem. The second part of the problem is asking us to calculate the milligrams. One thing that I didn't mention before is that there is no way to use dimensional analysis to obtain body surface area. So this is the one part of the math in this class that will not be dimensional analysis because there is not a way to figure it out using dimensional analysis. But the second part of this problem, luckily enough, we're able to use dimensional analysis for. So we're looking for milligrams. We know that we can go ahead and we can write milligrams on the left side of our equation, and we're going to carry milligrams over to here. There should be a line here. Since we have milligrams here, we're going to look up to our problem, and our problem from the healthcare provider says that we're going to give 750 milligrams per meter squared. So we have 750 milligrams over that 1 meter squared. If you need to put the 1 in, go ahead and do that. And now we're going to enter our data from the last step when we figured out how many meters squared this client is. And here's where we have to have this number that is in a hundredths position for increased accuracy. When you think about a patient and their whole volume is represented with a number less than 2, you want to make sure that that's an accurate number. So then we're just going to go ahead and take 750 times 184. Our meters squared canceled out, so we're left with just that label of milligrams, and then we get 1,380 milligrams. All right, so the next step then would be looking at what happens when the pharmacy gives you 20 milliliters of medication, and each milliliter of the medication contains 50 milligrams. So then we go ahead and we enter in that data, and we obtain 27.6 milliliters. So to just back up and highlight again what I did in that last step, the next part of the problem then is looking for how many milliliters to administer. So we know how many milligrams to give, but we don't know what that volume is. So we're looking for milliliters. We go ahead and put milliliters up here, and when we look at our problem, we have 20 milliliters in a vial that has 50 milligrams per milliliter. Again, weed out this extra information. They're basically telling you that you have a max of 20 mils available in that vial, but that's not a concentration or a dosage. It's just telling you you bought a gallon of milk instead of a quart of milk. It's just telling you the size of that container. So the information that we really need to know is how many milligrams per milliliter. So here's where we have our 1 milliliter over 50 milligrams, and then we're going to enter in that 1380 from that last equation. Our milligrams cancel out, and we take 1380 divided by 50, and we get 27.6 milliliters. All right, so now we have done part 1 and part 2. So we're going to go ahead and we're going to do another example like this. So we're going to have a medication that is to be administered once weekly. We're going to give 375 milligrams per meter squared, and we have kilograms and centimeters represented in this problem. So the first part is to figure out the dosage that we should give and round to the nearest 10th milligram. And then once we figure out the dosage to give in milligrams, we're going to figure out how many milliliters that nurse would administer, and we're going to round that to the 10th place as well. So the first thing that we need to figure out is body surface area, because when we look at this problem, our healthcare provider is not telling us that we're going to give X amount of medication per kilogram. They're saying meters squared. So that's why we know we have to figure out what is meters squared and how are we going to obtain meters squared from kilograms and centimeters. And we now know this fancy formula, so we can do that. So we're going to take our kilograms times our centimeters, and we get a number of 10,112. And we're going to divide by 3,600 because that's the magical number that we always divide by in this equation when we're using kilograms and centimeters. And we get 2.81. We're going to have 2.81 in our calculator and push that square root button, and we get 1.68. Remember, we're never going to round, even though our instructions say to round to the nearest 10th milligram. Again, right now, we're not rounding to milligrams. We're looking for meters squared. So your 100th spot is that second decimal. We're never going to round to that first decimal. These rounding instructions are for after you obtain that dose in milligrams, but we're not at the final part yet where we need to round. So we're going to leave this at 1.68 meters squared. Now that we know what meters squared is represented in, now we can go ahead and we can figure out how many milligrams to give. So again, dimensional analysis, we need to start out our problem with what we're looking for. We make that equal sign, and then we go ahead, and the very first part of that numerator is that milligrams. We look up at what is given in our problem, and our healthcare provider says you're going to give 375 milligrams for each meter squared that this client has. Here's where we enter in then our 1.68 meters squared that we figured out by using that square root function, and our answer is 630 milligrams. Now, if you look back, I'm telling you to round to the nearest 10th milligrams, and this happened to come out to a very even number. I want to just point out that just because I tell you to round to the nearest 10th doesn't mean that you should ever add a trailing zero. This is your 10th spot. When I say round to the nearest 10th, that's just given in the case that you would need to round. If you get an equal number or a number that's less than that, you will never ever add on this rounding zero. So just because I say round to the 10th doesn't mean that you add zeros to get to a 10th spot. It just means should the need to round occur, round to this place value. So then our answer would be 630 milligrams. Now, we need to figure out, we know how many milligrams to give, but we have this volume of medication in front of us. We still don't know how much to draw up in the syringe or how much to administer to the client. So now the second part of the problem says how many mils to give. So we're looking for milliliters. We write that on that left side of the equation, and we know that we have to start out this numerator here with milliliters. So when we look, our pharmacy supplies 10 milligrams per milliliter. That has to stay together in that equation. It's married. The pharmaceutical company sent it that way. I can't make it stronger or weaker. That's how it is. Again, we're looking for milliliters, so we know we need to somehow get rid of milligrams, and by putting milligrams as the numerator of this next equation, we are able to eliminate that, and we're going to enter in that 630 that we got from the last step. And so when we go ahead and take 630 divided by 10, we get an answer of 63 mils. Again, this is telling us to round to the nearest 10th, but we didn't have to round. We got an even number, and so we're going to just enter 63 into Respondus when we take the quiz or the exam. We never enter the label, so you would enter just 63. Never, ever a decimal and a trailing zero. Ever. Okay, so that concludes the lecture on Chapter 11, Integrity, and I just want to highlight one other thing for you. I have quite a few extra problems because this is an area that students really struggle at, and I want to make sure that we have adequate help available for you. So I'm going to go ahead and I'm going to go into Nursing 227, and I just want to highlight for you that in Nursing 227 I have some extra worksheets set up under Horntvedt resources here on the bottom left. There are some generic resources that came with the textbook, but I have quite a few. I have 20 extra problems from Chapter 11 listed here, and then I have the solutions right below them. So if you want to make sure that you get a good grade on this quiz and you want to practice, and maybe you're not terribly comfortable with math, go ahead and do those problems and then click down here and I have the answers. So take some time, get comfortable with these, and reach out to your local faculty or let me know if you have any questions or concerns. Have a great rest of the day.